Hello. This is, this is the first puzzle in a pack of 6 puzzles from Blobz, as part of a little snack puzzle series. It is based around the numbers 1 to 6, and you can see here I have all those puzzles opened up. So hopefully they are all visible, and hopefully I will be able to solve them all, in a row. So let's just jump right into it. The first puzzle, singular sensation. Can you see the rules? There you go. There's all the rules. Alright, so singular sensation by Blobz. Normal Sudoku rules apply. So digits 1 to 6, this is 6 by 6 Sudoku, so the digits 1 to 6 in every row, every column, and every 2 by 3 box. Whisper. Adjacent digits along the grey line must differ by at least 3. So these 2 digits differ by at least 3, these 2 digits differ by at least 3, and these 2 digits differ by at least 3. Killer. Digits in cages must sum to the small clue in the top left corner. So these digits sum to 11. And numbered rooms. So this is a new variant, we have never seen this before. But clues outside the grid, so these ones here, indicate the digit which has to be placed in the nth cell in the corresponding direction, where n is a digit placed in the first cell in that direction. So if this 1 says, if this is a 3, then the third cell in the direction here must then be a 1, because it has a 1 outside. So that's what numbered rooms mean. So with that, I guess we will begin solving. So, what do we do first? Well, whisper lines in 6 by 6s are slightly different from whisper lines in 9 by 9s, wherein you can have every digit on here because every digit does have another one that is at least 3 apart, whereas in a 9 by 9 you can't have 5 on the line. This you can have any digit you want. But I do believe that because of how whispers work, it is still going to alternate between highs and lows. So from the digits 1 to 6, you can split them into 2 groups of differing polarity, 1, 2, 3, and 4, 5, 6. And you cannot ever choose 2 digits from the same polarity that differ by at least 3, meaning that any 2 adjacent digits will include 1 from the low end and 1 from the high end. And therefore we can say that alternating digits must have alternating polarities. Although we don't know which is which, they must have alternating polarities in some way. Okay, I guess what we could look at next is these ones here in the same column. What does that mean? Well, wherever the 1 is, these digits, they refer to the same one. So if 1 was there, they would refer to the same one. What does that mean? Well, in fact, this refers to the same one as well, if it was in this position. Okay, say the one was here, then this would have to be 3 and that would have to be 4, right? Because this is 4 from here and 3 from here. What if you had a 1 on the end? Well, it's fine because it points to itself. Because, yeah, this 1 is in the first position, which works, and this would have to be 6, I guess. Which works as well. Huh, okay, so a lot of stuff does work. Maybe it's this long stretch then. Because each of these, yes, okay, well, yes, if you think about it, right? Well, alright, I feel like I should mention it in either case. Along this whisper lines, 3s and 6 are of particular... 3s and 4s are of particular concern, because 3 only has one possible partner. It can only be beside 6. That is the only possible value. And 4 can only be beside 1. It has only one possible value. So what that means is that since this digit must be differing by 3 with at least 2 other digits, it cannot be 3 or 4. And similarly, this can't be 3 or 4 because it differs by 2 digits. This can't be 3 or 4 because there's 2 digits around it, and this can't be 3 or 4 because there's 2 digits around it. That must be different in this case. It must be different because they're in the same row. So what we're saying is that 3 and 4 cannot appear anywhere on this line, and so 3 and 4 must appear on the outside. Now this one clue comes into play because this 3 and 4 implies that the 1 is in one of these cells. It's either 3 away or 4 away. And so whichever this 1 is would affect these clues, because wherever the 1 is, this must now be 4 in order to you know, look at the 1 in the same row. Okay, might be useful. Now 11 without the 4, it could have a 1 in it. And I guess it doesn't have to, because you could have like 2, 3, 6. That would add up to 11. Okay, now what I can say is that, yeah, because of these two 1s, the 1 appears in one of these cells. If 1 was here, this would be a 2, because it must look at this. But this is, if this is a 1, then it's just a 1. So it's either a 1 or a 2. Okay. Beyond that though, I'm not sure what else I'd have. I know that none of these can be 4, because 4 can only be next to 1. And so there can't be a 1 there. So none of these can be 4s. But that doesn't really do anything else either, does it? Ah, the 4 is outside. Yes, it means that 1 cannot appear in the cage. Why? Because if 1 were in the cage, you need a 10 in 2 cells. And the only way to make 10 in 2 cells is a 4 and a 6. You can't have 2 5s. You can't have a 7 or greater. So the only way to make a 10 is 4 and 6. But that's no longer possible because 4 is in one of these cells. So 1 cannot appear in this cage. Therefore 1 is in one of those cells. What if 1 was in one of these cells? I mean, then it will point to itself, which is fine. If 1 was here... Okay, well, I can, well... No, if 1 was here, then 1 is there. And then these are all resolvable, yes. So 1 could be there. I was gonna argue from a uniqueness point of view, but firstly, that's not even correct, and secondly, that's not how one will regularly solve puzzles like this. Okay. So 1 and 4 are already outside, meaning that 2, 3, 5, and 6 are remaining in here. Well, then we can obviously tell you what this is, right? Because, you know, I think the only way to make 11 in 3 cells without a 1 or a 4 would have to be 2, 3, and 6. And I believe that's forced. Ah, and that now means that 5 must be in this cell. Because 5 can't be in any of these cells. Otherwise there will be a 5 in one of these cells, which would break because we know there's no 5 in one of these cells. Yes. So 5 can't be one of those cells, so 5 must be there, which implies that this is 1 and 4. So this is now the high end, and therefore we know this can't be a 1. So this is a 1, meaning that this is 3, that's 4. This 1 means that this must be 4 to see this 1 here, and so that is 1. Okay, so now this 5 must be at least 3 away, therefore it's 1 or 2, but it can't be a 1, so it must be 2. This is a high end but can't be 4 or 5, so it's a 6. This is therefore 5 to complete the column. This is also 1 or 2, because 5 can only be next to 1 or 2, which is fine. This works in either way. You see, you could have 2, 1 here or 1, 2 here. That works. This could be a 1 if this was a 2. Ah, therefore we know that this always has a 2 in it. Because if this is 1, this is 2, Otherwise, if this is 2, then it's just 2. So this can never be 2. Okay. That is something so far. Do we know the 1 is here? No, the 1 could also be there. Which places 2 here? In fact, oh, 1 could be in any of those cells. Meaning that this is... Oh, yes, 1 can't be here. Because by this clue, if 1 was here, then this would have to be 5, because it's 5 away. So this can't be 1. So it must be 2. That's 1, that's 2. The 1 is in one of those cells, but 1 can't be there, because that will force this to be a 2. So 1 is here, making this a 6. Therefore, this 6 sees that, that's 3. This is 4 for the column. That's a 2, 6 pair, which is resolved by this 6. That's 2, that's 6. 2 in this box. Sorry, 2 in this box goes there. This is 3 and 4 to complete the row. This is 5 to complete the row as well. This is 4 and 6, which removes 4 from this cell, so that's 3, that's 4. This is 5 to complete the column. This is 3 and 6, this 6 sees that, so that's 3, that's 6. These are 2 and 5, which is resolvable. 5, 2, this is 1 and 3, which is resolvable. This is 3 and 4, which is resolved by this 3. 4 here, 3 there. This 4 sees that, so that's 6, so that is 4. This is therefore 5 and 6, which we can resolve as well. Solving the puzzle. Alright, that was pretty cool. And that is Singular Sensation by Blobz. Alright, second puzzle. Two's Company, also by Blobz. Oh no, you can almost barely see the numbers on the outside. I think you can tell those are 2s though. Yes, okay, all the clues are visible. So, alright, let's look at the rules of this. Looks pretty similar. So Whisper, digits along sorry, normal Sudoku is applied. Digits 1 to 9 in every row, every column, and every 3x3 box. Whisper, adjacent digits along the grey line must differ by at least 3. Okay, so I see something similar going on here as we had with the very first puzzle. We could probably use that. Yes, crop key. Digits separated by a white dot are consecutive, so these 2 digits are consecutive. Not all such dots are shown, so these could be consecutive, that's fine. And finally, numbered rooms. So clues outside the grid indicate the digit which has to be placed in the nth cell in the corresponding direction. So if this was a 2, then... Sorry. If this was a 4, then this would have to be 2. If this is a 5, then this would have to be 2. And so on. Because this digit tells you how far away this digit is. So those are rules. With that, let us start solving. So here I notice that we have this stretch of 4 cells, which is very similar to the stretch of 4 cells we had here. And I can therefore use the similar... Oh no, I cannot. Because this is not the same. This is the same, this is the same, this is the same, but this is not. Because this could be a 3 or a 4 if it was adjacent to like a 6 here. So I cannot use that logic anymore. Okay. Well, that is really unfortunate. It is quite close though. We know 3s and 4s on the outside. Oh, but 2s are interesting as numbered rooms, and in fact anything that's not a 1 is very interesting. Because now we have eliminated 2 from here, and in fact 2 from any edge touching a 2 clue. And the reason why is, if this was a 2 for example, that would be saying that the second digit in this direction must be a 2. But that's then saying that this must be a 2, which fails. And in fact, as long as this is not a 1, it will be pointing at some other cell, which fails, because then you would have a repeat. So if it's a 2, you can't have a 2 right beside it. And therefore implying that none of these can be 2s. Or similarly, none of those can be 2s. So 2 is in one of those cells. 2 is either next to 5 or 6. 2 can be next to 5 or 6. Okay. I don't think this can be 2. Yes, this can't be 2. Because if it was 2, then this actually follows the same logic as the 4 length line. Because now this is no longer 3 or 4. Meaning that 3 and 4 are outside. But if you notice, this cell never sees that. Because this is 3 or 4 which sees those cells. So this can't be 2. And in fact, this can't be a 2 either, because if it was 2, then this would have to be 6, which pushes 3 and 4 on those lines. We know that this could be 3 or 4, but no other digit can be 3 or 4. So that can't be 2. So we've removed 2 from this position and this position. And actually we removed 2 from these 2 positions as well. 2 also can't be there, which is... Yes, 2 can't be there because this implies that this would have to be 2, because the 2 here in this row is the second digit. So that would repeat the 2. So this can't be 2 either. And so in this row, 2 must be there. Which then implies that this... I'll remove the color now. This must be 4, because 2 is 4 digits away. And these 2 digits must be 5 and 6, because those are the only digits from 2. Now these are 1 and 3, and we know that this can't be 3, because 3 does not have 2 digits that are differing from it by 3. So this is 1, that's 3. 3 in the corner. These must be high and can't be 4, so these are 5 and 6. And in fact, we can start coloring all the high digits in, which are orange now. And low digits we can color as blue. Okay, so yes, okay, well I should have also said that this numbered clue room also, not only can it not have its own digit in its first position, it cannot have its own digit in its own position either. And the reason is because a digit in its own position will put the same digit in the first position, which doesn't work. Okay. So we have some digits. Well, this is actually 5 or 6, which means that 2 is in one of those cells. Because it's either 5 away or 6 away. If this is a 2, then that's a 4. But I think that's okay. And if this is 2, then this would be 5 and 6. Which I think is okay as well. This can't be 2 because it's high. This can't be 2 either. And... oh, okay. Very cool, very cool. This row is now interesting because we can actually eliminate 2 from all these cells. And the reason why is 2 can't go there. Because, you know, 2 in the column. 2 can't go there because it's a high digit by polarity. 2 can't go there by this pointing set of 2's here. 2 can't be its 2 can't be its own 2 can't be in the first position because that will put a 2 in the second position. And 2 can't be in the second position because that will put a 2 in the first position. So interestingly, by 5 different by 5 different types of logic here, we can eliminate 2 from all 5 cells. That is just so awesome. So that puts 2 in the final digit in the row, which means that's a 6. 2 is in one of those cells now. But 2 can't be there because that places a 2 there. So 2 is here, that places a 2 there. Meaning that this must now be a 4. And this must now be a 5 because 2 is now 5 digits away. Wow, that is so cool. This is now a 2-3 pair. 2 is in one of those cells. Okay, we don't know which is what though. And then these are 4, 1, 5. This is not 4. This can't be 1. If it was 1, then this would be 2. So this can't be 1. If it was a 4, it would be a 5. If it was a 5, it can't be a 6. So it's a 4. If it's a 4, it's a 5 or 3. So I can see this is 3, 4 or 5. Maybe. This is 1 or 3 because it can't be 2. This is 5 or 6 because it can't be 4. This is also 1 or 3. And in fact, it can't be 3 because the 3 must be next to a 6, which fails. So this is 1. This is 4 or 5 because it can't be 6. And therefore forms a 4-5 pair. So that's 3. That's 1. This must now be 4 because it can't be 5. That's 5. This is no longer 1 or 4. So that's 5. That's 1. This 5 sees that. So that's 6. This can't be 2. So it's 1 or 3. Which is fine actually. Okay, I could probably do some Sudoku here. 4 sees that, so that's 6. That's 4. This is a 3-5 pair, which we can resolve. 3, 5. This is 6 and 5. The 6 sees that, so that's 5. That's 6. This could still be 1 or 3. This is 1 or 3. This one sees that now, so that's 3. That's 1. That's 3, which works. This is 1, 4, which we can resolve. This 3 sees that, so that's 2. That's 3. These are 2, 5, 2, 4, and 5. This can't be 4 or 5, that's 2. This is 5, and that's 4. Solving the puzzle. Wow. I really like this row specifically, which we can remove so many different digits from here. That's just so cool. That's so cool. Okay, well that was fun. Let's do the next puzzle. That's 3 in the corner. Alright. So we got a couple new types of rules here. Skyscraper, no longer numbered clues. Okay. So, normal Sudoku rules apply, digits from the 6 in every row, every column, and every 2x3 box. Ranban, so pink lines, these pink lines, contain a set of consecutive digits in any order. So, well, I mean, they're 6 long, so I can definitely tell you that these contain the digits from 1 to 6. But also, it's because they're in the shape of a 3. They must contain, you know, because if this was a Ranban line, for example, then these digits must contain consecutive digits. So, for example, 3, 4, and 5, but they can be in any order that you want. Alright, next, killer. Digits in killer cages must sum to the small clue in the top left corner. So, well, these digits sum to 3 basically. These two digits sum to 3. Quadruple. Digits in circles must appear in one of the cells touched by the circle. So this circle touches these cells, so they must contain a 3 in them. Little killer. Wow, so many rules. Digits along a diagonal indicated by an arrow outside the grid. So this clue here looks at these 2 cells. These digits sum to the attached value. So these digits sum to 3. Skyscraper. Digits in the grid represent the heights of skyscrapers. So if you had a 1, 5, 6, 2, 4, 3 here, this would be 1 unit high. This would be 5 units high, 6 high, 2 high, 4 high, 3 high, and so on. And what this outside clue is saying is that, you know, it is, if you look from this direction downwards here, how many can you see if higher skyscrapers block lower skyscrapers from view? And so this is valid because this 3 cell here would see this 1, it would see this 5, it would see this 6, but it wouldn't see anything else because that's all obscured by this 6. So it would see 3 different skyscrapers, and so it's a 3. And finally, digits separated by a white dot are consecutive, so these are consecutive digits. And not all such dots are shown, so 2 digits here can be consecutive if you want them to be. And those are all the rules. Those are a lot of rules. Hopefully you got all of that. With that, I will begin solving. So I'm definitely going to start with these 3 cages. Those must be a 1-2 pair, no other way to solve them. And in fact, this 3 diagonal here must also be 1-2 because digits cannot repeat in the same box. This is a 1-2 pair. Ah, and I see. Okay, I see what to do here. This is a 6-digit long Ranban, which therefore must contain all digits from 1 to 6. Because that's the only set of consecutive digits, you know, from 1 to 6. It's just 1 to 6. But we have a 1-2 pair here, so none of these are 1 and 2. This 1-2 pair here means, well, none of these are 1 and 2. And therefore, in this set of 1 to 6, 1 and 2 can only appear in these cells. Which does help a lot because it forms a lot more pairs. For instance, you have a pair in this column, a pair in this column, a pair in this row, and a pair in this row. 3 here and 3 here form a sort of, well, we can then say in this column, where does 3 go? 3 can't go in there, and 3 can't go in there because 3 is already in here. So 3 is in one of those cells. Yeah, okay. 1, 2 can't be there, it can't be there, but it could be in 3 possible spots, so it's no longer another pair here. Yeah. Alright, so it might be time to look at, well, I could look at this property dot first before we keep going. If this is a 1, that's definitely a 2. If it's a 2, it could be a 1 or a 3. So it's 1, 2, or 3. Okay, well that's all I got. Let's time to look at the skyscrapers, I believe. Yes, because, well, there are a few tricks related to skyscrapers. And the idea is that, well, this 1-2 pair is already very suspicious, looking at this cell. The idea is that 6 is always visible. And the reason why is because wherever you have 6, whatever you put in front of it can never be taller than 6. Because you can't have 7 or higher. So 6 is always going to be seen. Not only will 6 be seen, the first digit is always seen as well, no matter what it is. It could be like a 3, it could be a 4, because there's nothing in front of it to obscure its view. So 6 will be seen, and and the front digit will be seen. This 1-2 sees that cell, so that can't be 1 or 2, which means it's at least 3. This is but it can't be 3 either, because 3 is already in the box. So this is okay, I see. So this is definitely just a 4. Why? Because if you put a 5 here, then the only other digit behind you can see is 6, meaning that this would be a 2 and not a 3. And same for 6. You can't actually put anything, you can't actually see anything behind the 6. So this would not be 6 or 5, and therefore it can't be 1, 2, or 3. It's therefore a 4. So that's our first digit. This is 3 or 4. And in fact, because of this 4 here, the only digits seen by this 3 are 4, 5, and 6. Which basically implies that 5 is in front of 6, because 5 must be seen. Yeah, and then 1, 2, and 3 are not seen at all. But that's a 4. This is not 4, this is 3 or 5, sorry. So 4 can't be in those cells. 4 is in one of those cells in this, like, sort of extra region here, because we know it's 6 long, it contains all digits from 1 to 6. So 4 is not one of those cells, 4 is in one of those cells. That doesn't really do anything. Although I guess this must contain a 5 or a 6 somewhere in there, because it can't be at 1, 2, or 4. So it will have 3, 5, and 6 in it. It has a 3 in it, and therefore must have a 5 and 6 in it. Yes, okay. And therefore it must be 3, 6. Because if it's 3, 5, the 6 will definitely be in front of it, which will block the view of the 5 here, wherever it is. So it can't be 3, 5, and it's therefore 3, 6. Making this a 1, 2, 5. This is no longer 1 or 2, so it's therefore a 5. That's cool. So these cells are now 3, 4, and 6. To finish this extra region. These are now 4 and 5. Now this can't be 5, because again, as we said, if it was a 5, it could only see a 6 behind it, and therefore this would not be a 3. So this is 4, that's 5. And in fact, this can't be 6 now, because we know of this 4, it must see a 5 and a 6. So if this was 6, it would block the 5 behind it. And so this can't be a 6, this is a 3, that's a 6. This is now, well, this is now 5 and 6, but the 5 must be seen, so the 5 must be there. 6 is there. This is now 3 and 4. Okay. That's quite cool. That 5 over there, sorry, this 5 here sees that, so that's 3. This is not 3. So 3 is in one of these cells. That doesn't say much. If that 3 is in one of those cells? Oh, 4 doesn't see that, so 4 is not there. In fact, this 1, 2, 3 pair means this is 1, 2, 3 pair. So 6 can't be there, because this is only 1, 2, or 3. So that's 3. This is 1, 2. This is not 3, 4, or 6. This is a 1, 2 pair which sees that, so that's 3. This 5 is not there, so 5 goes there. 6 goes here to finish the column. This is therefore a 4, that's 6. This is 4 and 5. This is 4 to complete the column. This is 1 or 2. Therefore that is 6 to complete the, well, 6 to complete a lot of stuff. It completes the row, the box, and the column. That is 3 to complete the row. This makes this a 4, that's a 3. This 4 sees that, so that's 5, that's 4. This is 5, 6, and so that's 5. That's 6. We have a lot of 1, 2 pairs to decipher. This 3 means that must be a 2, because it must be consecutive. So that should help us disambiguate everything else. So that's 1, that's 2, that's 1. This one sees that, so that's 2, that's 1, that's 2, that's 1. Solving the puzzle. Nice. Okay, well, I really enjoyed using these as extra regions. The Yeah, this is quite cool. Okay. Let us move on to the next puzzle. Petit Four. Yes, okay, all clues are still visible. Actually, I didn't check if the 3 had all visible clues. I think it did, yeah. Very snugly into the grid as well. Okay, so, Petit Four. Let's go to rules. Normal Sudoku rules apply. So digits 1 to 4 in every row, every column, and every 2x3 box. Renban. So pink lines contain the consecutive digits in any order. So similarly to the previous one, these are 6 lines long, 6 digits long, so they must contain all digits from 1 to 6. Fair enough. Quadruple, so digits in circles must appear in one of the cells touched by a circle. So one of these cells is a 4. Sorry. Oh, killer. I didn't see this. Killer. Digits in cages must sum to a small clue in the top left corner. So this sums to 4, basically. Little killer. Digits along a indicator diagonal must sum to the attached value. So these digits sum to 4. And skyscraper. Digits in the grid represent heights of skyscrapers, which we've known. And clues outside indicate the number of skyscrapers visible in the corresponding row or column, where taller skyscrapers obscure smaller ones. So this rule set is actually very, very similar to the previous puzzle. I won't go about explaining the rules again. Let us just begin solving. Well, this 4 cage must be 1 and 3. That's the only way to make 4 in 2 digits. And similarly, these 2 digits cannot repeat, so that's 1, 3. This 4 clue it sees 1 or 3. It could see 3 if it saw 4, 5, and 6 as well. Oh, I see. Okay, this 4 here and this 4 here imply that there are no 4s in those cells. So 4 are in those cells. Yeah, 4s are in those cells in each of these quadruples. This does work out. But one of these are 4s. Can I say that? Well, I can't say what, but... no. Yes, okay. 4 can't be there. That's a very small deduction, but if 4 was there, you could only see 5 and 6, making this 3 or less. But 4 could be there if this was a 3 though. So you could have 3, 4, 5, 6. So 4 could be in any of those cells, which is a lot more than I would like. I would preferably, you know, reduce my options down to 2 cells instead. Okay. Well, there's not a lot going on here besides just the quadruples, renbans, and skyscrapers. So I assume I'd have to do something involving those. Well, I know in this box, 4 is in one of these 2 cells. That is, if 4 was here... Yeah, okay, so we can tell where 4 is in this cell. If 4 was here, then it's just there. If 4 was here, then it removes 4 from those cells, places a 4 down there. But that fails, because you then have 2 4s in the same renban line, which does not work. So this can't be 4, so 4 is there. 4 is there. Therefore 4 is removed from all these cells, putting a 4 there in this quadruple. Same here, 4 is removed from all those cells, putting a 4 there in this quadruple. Why did I put 3? 4. And so the only way to make this a 4 is if, you know, this was a 3, so you could see 3, 4, 5, and 6. Therefore this is not 3, that's 1, that's 3. Okay. In this box, 3, well, this 1, 3 pair sees those cells, these 3 sees those cells, so 3 goes there. Okay. These are 2, 5, and 6, and I will pencil mark them. 1 in this set actually, or in this box I guess more normally. This one sees those cells, this one sees those cells, so 1 goes there. So these are 2, 5, and 6, which means 4 is in this cell in this row. That is 2, 5, or 6 as well. I guess we can put 4 in this box, so 4 goes there. That's all the 4s, I believe. Which works. What is in one of those cells? Oh, in this region now, actually, that's really interesting. This 3 sees those cells. This 3 sees those cells. So the only place you can put 3 in here is there, making this a 1. So that's a 3. So 3 in this box must now be here. 1 in this region can't be in those cells. So 1 goes there. This is 2, 5, and 6. This is also 2, 5, 6 to complete the column. And this is 2, 5, 6 to complete the row. 1 in this region. This one sees that. This one sees that. So 1 must be there. This is 2, 5, and 6. This can't be greater than 4. Because if this is a 3, then you must see 3, 4, 5, and 6. So 4 must be in front of 5 and 6. So this can't be 5 or 6. That's a 2. Okay, remove 2 from a lot of cells here. This 5, 6 pair means that's a 2. That's not 2. I guess 1 in this box. Yeah, 1 in this box must be there, so that's 1. This is 2, 5, 6. This is 2, 5, 6. These are all 2, 5, 6. Now what? This 4 clue, maybe we haven't used that at all. This can't be 6, because 6 will block out a 5. And this can't be 6 either, because the 6 here forces it to be a 5. Which fails, because 6 can't block 5 again. So that's not 6, meaning 6 is there. Therefore, this is a 5, that's a 6. That's a 6. These digits doesn't have to be in any specific order. This 2, 5 pair means that is a 6. What? Wait a minute. Something's up. How does this work? Did I do something wrong with pencil marking? That must be a 2, right? In this region. Interesting. So that's a 2. Which means that's a 2. So that's a 2. Okay, yeah, I messed up. I said this can't be a 5 and... I said this can't be a 6 and can't be a 2. Which is not true. This could be a 2. And it is. Now that I have redone my evaluation. This 4 here means that this must be smaller than this, because the 5 must be seen and the 6 must be not blocking the 5. So that's 5, that's 6, which resolves everything. Oh, what the? Wait, what? I am tripping. Wait. Hold on. Something's... Did I do something wrong? That's 5, that's 6. But somehow this leads to this cell being neither. 6 here, 5 there, 6 there. Yeah, what the? Wait, what? That's 5. But that's 6, making that a 5. What? So wait. Something else is up. Whoa. This looks fine, but it's actually not. What? Those two cells, those cells are always the same? Those cells are the same. Oh, wow, really? Yeah. This cell is always the same as these cells, which breaks. Oh my goodness, the puzzle is going a bit wonky. Did I do something wrong with the 1, 3s, and 4s, maybe? I probably did something wrong with the 1, 3s, and 4s. So I'm gonna remove all that. What was my logical deduction here? 3 goes there. It does because of these 3s. Hmm. Three is there. And then this is 2, 5, and 6. That's 1. And then these are, well, that's 1 there. And then these are all 2, 5, and 6. So right now, Or is it the same issue where I assume this could not be a 2? Why did I remove 2 from both of these cells? In fact, you can't even tell where 2 is. 2 plays 0 part in this skyscraper, so it can be anywhere. The only thing that can't be here is a 6. That's it. And this can't be a 5. That's it. Because a 5 here would force a 6 in front of it. So that's all we can say. This could be anything. Yeah. So similarly here, this can't be a 6 because it will block 5. And this can't be 5 because it will be blocked by 6. Okay, so something must be different then. Or... oh, right, is this 4? Because this... yeah, this 4 makes that a 5 and 6, right? This 3 means that only the 4, 5, and 6 can be seen after that. 3, 4, 5, 6. So it must be like this. So... what? Wait, am I doing something wrong? I think I am. Yeah, what? Wait a minute. Wait a minute. Something's wrong. Something's wrong? What did I do? What did I do? It's some previous logic, I think. Remove everything first. I still believe that this set of 3s and 4s are fine. And the reason I went about deriving that was that 4 here forces a 4 there, which does not work. This is Renban, correct? Yes. And so these are 6 consecutive digits, which are 1 to 6. And therefore cannot repeat. This 4 sees those cells, which puts a 4 there, which puts 2 4s in the same digit. So 4 can't be there. So 4's there. So 4's there. Now 4 can't be here. And so in this quadruple, 4 must be there. And I can do the same here. So up to this point, I am still okay with my logic. Oh, this can't be, this doesn't have to be 3. Yeah, this just has to be smaller than 4. Right. That was the one mistake I made. I said this must be a 3. Okay, this doesn't have to be. It could be 1. That's fine. It just has to be that 5 and 6 are also visible from behind. It could be something smaller than 4, and then something, 5 and 6 in the back. So yeah, okay, that is a mistake that I made. Okay, so 4 still goes here in this box, 4 still goes there in that box. So yeah, making this a 3 was an absolute mistake. I will keep all of this in the video though, just for authenticity. And I make sure I can show that I got through all of this logically, even with all the mishaps and all that. This, wait, well, this, could this be 5? No, because 5 can only be seen, with a 5 here, you can only see this digit, 5 and 6 behind it. So this can't be 5, and it can't be 6 either for the same reason. So it must be 2. Yes. So this now can't be 5 or 6 either, because if it was 5 or 6, well, no, sorry, 5 here can actually work because you could have 6 behind it and then a 1 here, and you see 1, 2, 5, and 6. That works. So this could be 5 or 6. This could be 5. Can't be 6 again. 1, 3. Yeah, 1, 3 in this region. Can't be in those cells. So 1, 3 is there. This is 5 or 6 to complete this, and then this is 2, 5 or 6. This is a 1, 3 pair. So that's 2, 5 or 6 to complete the column. This is 2, 5, 6, but this could be 2, and we don't know. It's very interesting about this 4 though, because this 4 must have 5 and 6 behind it. Although it doesn't really tell us anything else much. If this is 3, then you must have 3, 4, 5, 6. Because 3 can only have 4, 5, 6 behind it, and this 4 forces 5, 6 behind it. This is a 1. That gives us a lot more potential, because the 1 now allows us to see both of these, as opposed to just this cell. So that is a little bit different. What else is there though? I mean, it has to be one of these 4 clues, right? This is 1, 3, or 5, I think. Because it could be 5 and it could be 1 and 3 as well. Actually, this can't be a 3. And the reason why is it's actually going over the limit as opposed to not being able to hit it. If this is a 3, that's a 1. You see all these cells plus a 5 or a 6 behind it. Oh, well, plus the 6 behind it, because the 6 is always visible. And that would make this 5, so this can't be 3. If this is 3, this is 1. If this is 1, then this is 5. Because 1 can't have 3 here. Okay. So 3 is in one of those cells now, in this region. Which means that this can't be 3. So that's 1, that's 3, that's 1. Well, is that 1? Could it still be 5? No, because this 3 must have 4, 5, 6 behind it. So yeah, this must be 4, 5, 6 like that, this must be 1. This is 3, 5, 6. So that's 2. This is 1, 3. This can't be 5 or 6, so that's 2. This 1, 3 means this is, along with that, that's 2, 5, 6. This can't be 1 anymore. I mean, we already know 3 doesn't work because we already tried 3. But I'm not gonna say that. I'm not gonna say just because we tried 3 and it didn't work, we're gonna put 2 in. This 5, 6 pair means this is 1, 2, 3. Which means this is no longer a 2. 5, 6 pair sees that, so that's 2. This is still 1, 3, 5, or 6. And that should not be too much of an issue. Alright, we're probably looking at this 4 clue now. Because after this 4, the 5 and 6 must be visible. So 5 can't be there, otherwise 6 will block it. This could be 6 if this was a 5. You have 6, 5, 2, 3. Which works. This could also be... No, this could be 6. You could have like 2, 3, 5, 6. Well, yeah, 2, 3, 5, 6. 6 can't be there, is what I can tell you. Because then it will block the 5 behind it. So 6 can't be there. Oh, well, if 6 can't be there, then 6 is in one of these 2 cells in a row. That removes 6 as candidates from these cells. Which gives us a chocolate teapot. Very nice. Wow, this is actually really tough to crack. Because I'm trying to find some way to say that this is not a 3. 3 here would make this a 4, 5. I mean, this is always going to be a 4, 5, 6 somehow. It's either 4, 5, 6 or 4, 5, 6. Which should work. Or 4, 5, 6. So this is not 1, 4, or 6, so it's 2, 3, or 5. Can't be a 2 either. So it's 3 or 5. And this is 1, 3, 5, or 6. And we have very little grasp on what that could be. Five here, 5 here. Would make... Well, it will move 5 from there. Oh, and then there will be like some sort of another kind of chocolate teapot. So no, that's not where we look at either. I'll say it might be something to do with the regions that I'm not looking at. But I think the regions are all basically done with, right? You already have the pairs contained within the regions themselves. So no matter how you arrange them, it will still work for the region. So I don't think I look at the regions at all. It is the 4, right? But like, what is the 4 even doing? Maybe we do some coloring, maybe. Because these digits are the same color. And in fact, in this row, these digits can't be there now. It can't be 4 or 1 or 2 and 3. So that digit is the same, meaning that digit can't be 2. Got it. And so in this row, 2 can only go there. I see these 2 digits were the same because in this row here, these 3 digits are the same as these 3 digits, and so these 2 digits must be the same. There you go. Okay, well that is some break-in. Wow. I mean, I don't think we're even done yet. Because that was just a 2, which doesn't even give us much information. Do we still need to continue coloring? Saying that those 2 are the same? Well, I mean, that doesn't tell us anything either. Well, these digits. Sorry. This digit sees those, this digit sees that, and this can't be 5 or 6. So that is the blue digit. Which means that since this is not blue, that's blue. In fact, I can probably color these as orange as well. Or pink. Those are the same digit. Oh, and therefore... Oh my god, the 5-6 pair has always been resolvable. Oh my goodness. So this must not be 3. That's 6, 5. It's always been resolvable. That's so dumb. I really was not looking at that. 6 here. That's 3, 1, 3, 1. Solved. Oh my goodness. Yeah, it has always been resolvable. I just was not paying attention to it. But there you go. Well, that was interesting. What a puzzle, am I right? Okay. Well, after that comes take 5, which I believe is a reference to some song, right? So that's the 5th puzzle. And actually we have a lot fewer digits here. Normal Sudoku rules apply. Adjacent digits along the grey line must differ by at least 3. So back to the Whispers rule. Killer means digits in cages must sum to small clues. So these 2 digits sum to 5. Skyscraper, we know skyscraper rules. So each digit has its own height. The 5 sees, 5 skyscrapers from this direction. So let us begin solving. Actually, I think the 5 is... Whoa. The button's in the wrong spot. The 5 as a skyscraper clue is very interesting because it sees a lot of things, and therefore it must be increasing in order almost... It just must almost be always increasing in order. It's not a numbered clue. So this must be relatively low then. Right? Because if it was a 4, 5 or 6, then you only have 3 or less in it. So this must be relatively low. And I can therefore color in all these digits as lower values, and these digits as higher values. And in fact, I guess I could just color them or pencil mark them 4, 5, and 6, and 1, 2, 3. Now these digits see repeating neighbors, or see distinct neighbors. And so distinct neighbors cannot have 3s or 4s in them. This sees 2, this sees 2, this sees 2. And that's it, so those can be 4. That is a 5, 6 pair. This is actually pretty low as well. It could be a 2. But it can't be a 1. Because if this is a 1... Well, no, it's fine. It could be 2... Well, okay. This 5 clue looks very interesting. Because the idea is that if this is 2, then this is 1, 4. But if this is 4, then now 1 and 3 are all obscured behind it, making this a 5? Making this a 4. Like the 1 and 3 are obscured behind it, so you can't fulfill the 5. Meaning that this would have to be 1, so that is not 1. And in the case that, you know, this is 1, then this is just not 1 either. So I can say that this is not 1. Probably. This digit, there we go. This digit can't be 6. It has to be a 5. And the reason why is because if it was a 6, then you'd be obscuring 2 digits behind it, which makes it impossible to fulfill the 5 clue. So that's 5, that's 6, that's 5. This is no longer 6. The 5 here sees that cell, which can't be 3 anymore, so it's 2. This cell now can't be 4, because it's next to a 2. Actually, this is a 1. That's a 2, that's a 1. So this is always going to be obscure. This is always obscure to 2. This is always greater than 2. So that means that these digits must be increasing in order. And because, this one, okay. This can't be a 1, 2, it must be a, sorry, what am I saying? This can't be 1, 4, and therefore must be 3, 2. This 2 sees that, so that's 3, that's 2. Now this is always going to be obscuring this. So all the remaining digits must be increasing in order to make 5 work. So it must be 1, 3, 4, 5, 6. Yes, that's the only way you can see 5 different digits once the 2 is obscured. Okay, well 6 in this box goes there. So that's a 4, 5 pair. This must be a 3 to complete the row. 3 in the corner. This is 1 and 4. This is not a 5. This could still be a 4. This is a 1. 4 in this box has to be here. That's 1. That's 4. These digits are now 2, 3, and 6. So this is not 6. That's not 2. That's not 3. These digits are 3 and 6 to complete the row. So that is now 6 because it can't be a... Oh, sorry, that's now 5. Therefore, this is not 3 because 3 is only next to 6. This must be 1 to complete the row. And this 5 sees that, so that's 4. That's 5. This 2 sees that, so that's 1. Whoa, are you hearing that? This is 3 or 6. This 6 sees that, so that's 3. That's 6, that's 3. I think the wind's very strong outside. This is 2 and 4. The wind does feel very strong outside, actually. This is... Oh, 1 in this column. Can't be there or there, so 1 goes there. Here we have, I think, 3, 4, 6. Oh, see, sorry, this 6 sees that, so that's 4. So this 4 sees that, that's 2, that's 4. This is now 5 to complete the row. This is 2, 3, and 6 again. But this can't be 6. Oh, sorry, this can't be 2, this can't be 3. And now we use this final 5 clue to help us disambiguate everything. Because the 5 obscures the 4, so all these must be seen, and therefore must be increasing in order upwards. So this is 2 and 3. That is 6, that is 2, that is 3, that is 6. Solving the puzzle. Nice. Well, this was a lot more smooth in terms of my solve than, you know, the previous one. But okay, I got this one done as well. This one was pretty fast, in about 5 minutes, which is very apt for this, you know, 5 themed puzzle. Let's move to the final puzzle, which I will try to solve quickly because I have lunch coming up. So let's see if I can look at it and do stuff. Alright. Normal Sudoku rules apply. Digits 1 to 6 in every row, every column, and every 2x3 box. Whisper. Adjacent digits along this grey line must differ by at least 3, which, you know, again, we can, well, we already know what those rules are. Anyway, killer. Digits in cages must sum to a small clue, so these two digits sum to 6, these two digits sum to 6, and so on. And finally, X sum. So this is a new one. Clues outside the grid give the sum of the first X digits placed in the corresponding column. So if this was a 3, then these 3 digits, where X is the first digit in that row or column. So if this is a 3, it's the first digit in the row, and therefore the first 3 digits in the row must sum to 6. So it must do something like that. So with that, let us begin solving. Now I think I can tell you that 6s as X clues are pretty interesting, because they only have 2 options for the first digit. It can't be 1, because then you're saying that this 1 digit adds up to 6, which doesn't work. It can't be 4, because you're saying that 4 digits add up to 6, which obviously doesn't work, because if you have 1, 2, 3, and 4, minimally it will add up to 10. And for very similar reasons, it can't be 5 or 6. Those are just ridiculous at this point. So it must be 2 or 3. Now if it was 2, then these 2 digits sum to 6, making this a 4. If this was 3, then these 3 digits sum to 1 or 6. Sum to 6. These 3 digits sum to 6. And because 3 is already used up, these must sum to 3, which are a 1-2 pair. So this set of digits come out of the 6 as per normal. So here we have 2, 3, here we have 2, 3, here we have 1, 2, 4, and here we have 1, 2. And actually a lot of triples start emerging. This is a 1, 2, 4 triple. This is a 1, 2, 4 triple, which in particular removes 2 from those cells, making them 3. Now these 3 sum to 6, so that is no longer a 4, that is no longer a 4. Whoa, that is not what I expected. Did I make a leap in judgment somewhere? Because if this is 2, then that's just 4. If this is 3, that's just 1, 2. So this must be from the 1, 2, and 4, right? Oh, this doesn't have to be. Right, this could be anything else. This doesn't have to be. If this is 2, 4, this could be like a 5. So this is in fact not a triple, because this is not 1 or 2. But this is in fact 1, 2, or 4, because this is always covered by this cell. So those are our digits. Therefore, I have made an absolute leap, or absolute lack of judgment. But I can say that that's a low digit. So I can continue coloring alternating values to say that these are all low digits, and alternating values which are high. And in fact, this means this is low and cannot be a 4. So this can't be 2. So that is 4. Sorry. This can't be 2. This can't be 2 because that would then be a 4, which fails. So this is 3. This is a 1, 2 pair, making that a 4. Therefore, this must be a 2 because it can't be a 3. Now this can't be 3 because that forms a 1, 2 pair here, which breaks this cell. So this is in fact 2, which touches a 4. This now can't be 2 and 4 because of the 2, 4 in the column. So this is a 1, 5 pair. These are 3, 6 pair, which we can place because 3 is always low and 6 is always high. 3 must be always next to 6, which is very good. This 2 is next to 5 or 6, but we don't know. I guess I can place them in. The same here. This 2 must be next to 5 or 6, but these can't be 6s, so they must be 5. Actually, this 2 sees that, so that's 1, that's 2. Right, okay. Well, that's something. This is 6 to complete the row. This is 1 or 2. This could be 3, but this is 1 or 2. These sum to 6. Not helpful right now. This is a 3 to complete the column. Should have seen that. And so 3 in this box must now be there. 3 can't be in the 6 cage because the other digit would then be 3. So in this box, 3 must be here. And therefore in this box, 3 is here. Placing a 1 there to finish the 3 in the corner. That's a 2. And therefore that is a 4 to finish the column. This could still be either, I think. But this we know is a... Well, this is a 1, 2, 5. Right, this 2 is over here. Sorry, this 2 in this box can't be there or there. So 2 goes there, which is accompanied by 4. This is now 1 and 5. these digits are 4 and 6 to complete the box. This is a low digit. But it can't be 2 or 3, so it's 1. So that's 5. That's 1, that's 1, that's 5. This is 2 to complete the row, so that's 4. That's 5, that's 6. This must now be 4, that must now be 6. And these are 1 and 5, which we can place. There we go, solved it. Oh, in less than 5 minutes. Very cool. Okay, I guess I'm just speeding up as I start solving this. The first puzzle was really more of a warm-up for me, so it took me so long. But finally, I managed to solve this puzzle in less than 5 minutes, so I'm very happy with that. So I hope you enjoyed all those puzzles as well. With that, well, it's already more than 1 hour recording. But with that, I hope you enjoyed those puzzles. I will see you next time. Bye bye.